Engineering students, today we're going to use TinkerCad to simulate building with Arduino a project that I'm calling Temperature Checker. Here's what the idea behind the temperature checker is. We're going to simulate this device that you've probably seen before, something like the thermometer that you might use to take your temperature when you're sick. It's going to use a component that's almost identical to the one that's inside that thermometer, and then we're going to use Arduino to simulate the microprocessor that's inside that thermometer. We're going to do a little bit extra too. In addition to just reading the temperature and printing it out on something called the serial monitor, we're also going to make some decisions based on what the temperature is and use that to turn some lights on. So this is an example of this device. I'm pinching the temperature sensor, and as the temperature rises, LEDs light up according to how hot it is, and then when I take my finger away and let it cool down, you can see that the LEDs gradually go out. So it's kind of a monitor of what the temperature is. So that's the idea. So things that we're going to need, we're going to have jumper wires. We're going to use some 220 ohm resistors. We're going to need 3 red LEDs, and then we're going to use a temperature sensor called the TMP36. It's a particular type of sensor that's been developed for microprocessor use, and it provides a voltage output that matches the temperature, or that's proportional to the temperature, I should say. So this is what we're going to build. It's not a super complicated circuit. You might want to just take a picture of this or have it in your mind so you can kind of follow along here and know what we're building. So the temperature sensor is off to the left, and it's got 3 leads. One is the signal, and then there's a power and a ground. And then the LEDs will wire up like we normally wire up LEDs. The anode side is going to get a signal from the Arduino from pins 2, 3, and 4, and then the cathode side goes to ground. So let's go ahead and build that, and we'll get into TinkerCad, build it, and then we'll write some code. Okay, here we are in TinkerCad. Let's get together the things that we need. We're going to need a breadboard. So I'm going to drag this breadboard in place. We're also going to need an Arduino, obviously. So search for that. Arduino. Okay, here's our Arduino. Drag that onto the board. I'm going to need an LED. 3 LEDs actually. Oh, there they are. So I'm going to drag 1, 2, 3 LEDs. I'm going to need 3 220 ohm resistors. So I'm going to pull a resistor on here and then change its resistance to 220 ohms. And do it again and do it again. And the purpose of those resistors is just to protect the LEDs from burning out. And then I'm going to need my temperature sensor. So I'm just going to do a search for temp. There's my temperature sensor, TMP36 sensor. And now I think I have all the components that I need, and it's time to start building. So the first thing I'm going to do is install this temperature sensor somewhere. This is probably a good place right there. I'm going to want one side of this to be positive and the other side to be ground. So I'll hook a wire from one of these outside legs to the positive rail. Turn that red, just because that's what we do. And then the other side is going to go to black, or is going to be black and go to ground. And then that inner lead is the signal that's going to go to Arduino. So I'm going to attach from there to the analog 0 pin. That's the A0 pin on my Arduino. Move this around so that it's a little bit out of the way. Okay, so now I've got that wire going, providing the input, and now we have to work on outputs. And the outputs are coming from Arduino's pins 2, 3, and 4 to the LED. So I'll install one LED, and then a second LED, and then a third LED there. On the cathode side, the negative side, I'm going to connect that to ground using my resistor in all 3 cases. And then the inputs to these LEDs come from Arduino's pins 2, 3, and 4. So I go from Arduino pin 2, digital 2, to the anode of my first LED. From pin 3, I go to the anode of the second LED. Let's change this to a different color. Maybe I'll use yellow. And then from pin 4, third LED. Change this to blue. Okay, we're almost done. We just have to provide power to our board and ground. So from the 5 volt, I'm going to hook up to the positive rail with a red wire. And then from the ground, one of the ground pins, I'm going to hook up to the negative or ground rail of my breadboard using a black wire. And there's my circuit all wired up. Now it's time to write some code. We got a few new concepts for coding this time. One thing that's going to be new is something called a float variable type. We've used variables before, but they've all been type int, which is integer, and that means just whole numbers. But a float allows you to use decimals. So we're going to need float variables, and we just define those using the word float, and then we just give them a variable name like we would an integer variable. Then another thing that's new is a serial monitor. So a serial monitor is where your Arduino sends feedback back to your computer and displays what it's outputting on a screen. So we'll have to put some lines of code in there, first of all, to turn the monitor on, and then to print to the monitor the things that we want to read. And then we have analog inputs, and analog to digital conversion is another part of what we're doing here. So analog inputs come from not digital, not high or low, or on or off, or 1 or 0, but variability. So this temperature sensor is going to send out a voltage that can range through a whole bunch of different ranges, and that voltage comes into an analog to digital converter, an ADC. And what that does is it changes the signal into something that's more like digital. It's whole numbers, actually, from 0 to 1023. So there's a 1024 increment range that this voltage will be assigned to. And then the Arduino code can read that and turn that into a temperature. The sensor that we're going to use, the TMP36 sensor, has this on its data sheet. So the engineers have done a lot of research after they built the thing, and here's what they know. The TMP36 is curve B on this graph, and if you look at curve B, at 0 degrees, the voltage output is 0.5. And at 100 degrees, the voltage is about 1.5. So that means in 100 degrees of temperature change, there's 1 volt of voltage change. So that's a slope kind of that's useful to us. And what that means is that we've got a value of 100 degrees C per volt. That's going to be important as we get into writing the code. And also the fact that it's 0.5 volts at 0 degrees C, that's also going to be built into our code. So these are things that you need to know to write the code. And I'll talk more about them when we actually get to the lines of code that use this information. So we're going to shift our voltage by 0.5 volts. That's part of our code. And the other thing is that allows negative temps. And then the other thing is we're going to multiply our voltage by 100 in order to get degrees Celsius according to this temperature profile that's on this graph. Okay, let's write our code. So go from blocks into text. Get rid of what's already in there. Okay, the first thing that we're going to do is we're going to establish an int. So this is an int variable. So we'll go int, and we're going to call it baseline temp. Int baseline temp. And we're going to assign it to the value 0. Don't forget your semicolon. So this is a variable that stores what we're going to call the threshold temperature. This is the temperature that's needed to turn on the LED. We're going to change that, but for now it's going to be stored as a 0. Now we're going to define our float variable, or a float variable called float, and we're going to name it Celsius, C-E-L-S-I-E-U-S. And we're going to assign that the variable 0.0. It has to have a 0.0 after it because it's a float. You can't have an integer. It's got to be a decimal number. We're going to have another float variable called Fahrenheit. That's how you spell Fahrenheit. And because it's a float variable, we also have to assign this a 0.0 value, not 0. Don't forget your semicolon like I did in the last line of code there. And that's it for our pre-setup. Now we're going to do setup, so void setup, and then open, close your parents, and then open a set of curly brackets. So here's your setup code. We're going to do 1 input and 3 outputs. So pin mode. The input is our analog 0 input, so A0, and then we're going to type input to establish that as an input. Don't forget that has to be capitalized. Semicolon, and then another pin mode. Pins 2, 3, and 4 are going to be outputs, so digital 2, output, and I'm going to copy and paste to save myself some trouble. And then just change the 2 to a 3 on this line to a 4 on this line. Okay, now remember we talked about the monitor, the serial monitor? We have to start that in setup. So we do a command called a serial.begin to do that. And then we have to specify how fast we're going to communicate. And we're going to communicate with 9,600 bits of information per second. So in parentheses, we put 9,600. That's a pretty common serial transmission rate in Arduino. So that's the end of setup. So we're going to close that curly bracket. And now it's loop. So void loop, open and close parens, and open your curly bracket for the loop. Okay, so now we have to do some math to convert the input that's coming into pin A0 into a temperature. First thing we're going to do is reset the baseline temp. So we're going to type that variable baseline temp and then set it equal to 40. So 40 degrees is going to be our baseline temp. Don't forget your semicolon. And now we're going to calculate the value of the Celsius temperature. And here's where we have to use that information that we found from the data sheet. So Celsius equals, or we're assigning to the variable Celsius this number that arrives from these calculations. So we're going to open 3 sets of parens, and then inside the inside paren set, we're going to type analog read. So an analog read is like a digital read, except for it's looking for a signal from 0 to 1023 rather than a 1 or 0. And it's going to read from pin A0. So we open a paren and go A0, close that paren. And then it's going to divide that by 1024. But we have to use 1024.0 because this is a float variable. I'm going to close the inside parentheses. Now this is going to be multiplied by 5.0. So what we've done there is we've taken what fraction of the total 1024 increments are coming into A0, and we've multiplied it by 5 because 5 volts would be the maximum voltage that would be coming from that pin. We're going to close the second set of parens, and then now we're going to subtract 0.5. The reason we're subtracting 0.5 is because, remember, at 0 degrees, the voltage is 0.5. So to orient our temperatures on the temperature scale, we're shifting it over by that 0.5. So 0 doesn't read as something higher than 0.5. That 0 is actually where 0 is supposed to be. Then we're going to close that last set of parens, and then now we're multiplying by 100. And the reason we're multiplying by 100 is because, remember, it's 100 degrees for every volt. So this will change the input voltage, or the input analog to digital conversion value, into a voltage, then subtract a voltage to shift over to where 0 should be, and then multiply by 100 to turn it into a Celsius temp. So we're finally done with that line of code. It's kind of complicated. We're going to close that out with a semicolon, like we always do. Okay, so the next thing we're going to do is we're going to calculate a Fahrenheit temperature. So we'll go Fahrenheit, and you got to remember to type it the same way you typed it when you defined it. So if you take any Celsius temperature and multiply by 9/5 and then add 32, that's Fahrenheit temperature. So we're going to take the variable Celsius that we just figured out. Got to spell it right. And then times 9, but it's got to be 9.0 because this is float. And then we're going to divide by 5, but it's got to be 5.0 because it's a float. And then we're going to add 32, but it's got to be 32.0 because it's float. I'm looking up at the line of code just immediately above that, and I see a problem. I've got a float variable I'm not multiplying by 100.0, so go back and change that. Okay, next line of code. It's going to be a serial print, so serial dot print. So what this is going to do is send to my monitor some value, and so what I want to print there is the Celsius temperature, so I'm going to put the variable name Celsius that I used up earlier, and then semicolon after it. And now I'm going to print a label for that temperature. So I'm going to do another serial print, so serial.print. And because this is a label, I'm just going to have it print a text string. So how I do that is I put quotation marks. I'm going to leave a space, the letter C, a comma, and then close my quotations. So things that are in quotations just get printed just the way they are. The Arduino, when it runs this code, is not going to look for a number there or something assigned a variable. It's just going to print what it sees. Now I'm going to print the Fahrenheit temperature, so another serial.print. And then Fahrenheit. That's a variable, so you got to spell it right. And then close with a semicolon. I spelled serial wrong, like C. Better change that. And then one more serial print. So serial.print, and we're going to change this from print to print line. So by putting an ln after that, what this does is it starts a new line after printing. So here's the label for Fahrenheit. So quotation mark, space, F, and then close quotation mark, close the parens, and then a semicolon. So it's going to print the label for Fahrenheit and then start a new line. Okay, so the next part of our loop is going to turn on our lights as appropriate. So we're going to use an if command to make those decisions. So I'm going to go if, and then I'm going to compare Celsius to the baseline temp, so the actual temp to what my threshold temperature is. So Celsius, spell right. If Celsius is less than baseline temp, then here's what I'm going to do. So open parens. The first thing I'm going to do is a digital write to low. So that means it's going to make sure that LED, the first LED, is off. And then it's going to do the same thing for the other two. So I'm going to copy and paste and change the 2 to a 3 and a 4. So if the Celsius temperature is less than 40 degrees, which is our baseline, then it's going to leave all of the lights off, or turn all the lights off, I should say. That's the end of that if, so I'm going to close my curly brackets. Now I'm going to put another if in here for the next condition. So if Celsius is is greater than or equal to the baseline temp. So I have to use greater than or equal to so that I don't run into a situation where the temperature does not fall into a range, because Arduino will freak out if it doesn't know what to do. So that's one condition, and then there's a second condition here. So I want it to be bigger than the baseline temp, but less than the baseline temp plus 10. So how I do that is I put 2 ampersands in there, 2 and signs. And then I put my second condition. The second condition is Celsius less than baseline temp plus 10. So that's my condition that I'm looking for. So if the Celsius temperature is bigger than the baseline temp, but is not as big as the baseline temp plus 10, in other words, if it's between 40 and 50, then I'm going to turn on the first light. So I open my curly brackets, and I'm going to copy this set of digital rights and just modify them. So in this case, digital output 2 is going to be written high, and the other 2 will just stay low. That's my end of my if, so I close my curly bracket. So I'm going to repeat this whole thing with slight modification. So I'm just going to copy that and paste. I'm going to turn 2 lights on if the Celsius temperature is between 50 and 60. So if Celsius temp is greater than or equal to baseline temp plus 10, and it's less than baseline temp plus 20, then I will turn on 3 in addition to 2. So I'll change that to a 3 to a high. And then you do the same thing again. So I'll copy that or paste it in place. And now I want to have another range where it's between 20 higher than baseline temp and 30 higher than baseline temp. So if baseline temp is less than or equal to, or Celsius is greater than or equal to baseline temp plus 20, and it's less than baseline temp plus 30, then I'm going to turn on all the lights. So high and high for pins 3 and 4. So all the lights will be on high if it's between 20 and 30. Okay, I'm going to do one more thing here. I'm going to copy this if again. And paste it, and I guess I already had that in my clipboard. If Celsius temp is greater than or equal to 30, then I'm going to do something else here. So, or baseline temp plus 30. So I'm going to take out a bunch of code in the middle here. So it just says if Celsius is greater than or equal to baseline temp plus 30, what I'm going to do is I'm going to blink all the lights on and off. So I'm going to take this digital right high and turn them all on. And copy that. And then I'm going to paste it. Then I'm going to turn them all off. So I'm going to change these highs to lows. But I want to have a little delay in here. So after this, I'm going to go delay for 1/4 of a second maybe. So 250 milliseconds before it turns off. And then I'll want to copy that delay down here. So they've been turned on, then off. So I'm going to turn them on again. So I'm going to copy this, paste it. So it turns them back on and delays for another quarter of a second. And then I'll copy the off. And then turn them off. And after this, I'm going to delay for a second. And the reason I'm going to delay for a second before doing the loop again is because if analog signals come into that port too fast, the Arduino will freak out. Okay, so now I'm done with loop. Actually, I have to close this if first, because that was a bunch of things inside that if. And now I'm done with loop, so I'll do my final close curly bracket, and there's my code. Let's see if it works. Oh, looks like I have some errors. Oh, I think I have an extra close curly bracket. Now let's try. One of my closed curly brackets is an open curly bracket. That's not going to work. Now let's try it. Okay, the simulation is on. Now you can simulate heating this up by clicking on the sensor, and then this little temperature scale happens. And I can boost this up, and you can see my lights light up when I make it hotter, and they go off when I make it colder. Let's look at the serial monitor. When I click on serial monitor here, you can see that it's displaying the Celsius and Fahrenheit temperature in real time. So I make it hotter. Temperature goes up. I make it colder. The temperature goes down. So there's an input that's analog. We're doing something with it and providing digital outputs, and then we're reading off a serial monitor. So that's the new stuff that we learned today.